working on this plugin for ChatGPT, bringing some of the power of Wolfram Alpha and the Wolfram language to ChatGPT. We were playing around sort of manually with ways that you might try to take the output from ChatGPT, go to Wolfram Alpha, go to the Wolfram language, feed some of that data manually back into ChatGPT and improve some of the results you get. Shortly after that, we were contacted by people from OpenAI, and they invited us to work on developing this plugin for ChatGPT. Initially, we had been thinking it would maybe just be a Wolfram Alpha plugin, and then realized there were some very cool possibilities if we had a combined Wolfram Alpha, Wolfram language, making use of the Wolfram Cloud plugin. And so we've been developing this at a very rapid pace over the last couple of months, and it's really great to see this finally come out into the world. So we, one of the things that we realized early on was, we have a lot of different APIs for Wolfram Alpha. We have spoken results, we have full results. Realized pretty quickly that we could probably get better results if we designed a new endpoint that was really specifically for ChatGPT or other LLMs to call. So we have a new endpoint for Wolfram Alpha, still very much undergoing development, that is designed for an LLM to call out and get Wolfram Alpha results in a format that's easier for it to consume and parse and get information out of than the kind of fully structured API results. So that's been great that we've been able to do that quickly. We've also had people working on the Wolfram Cloud side, and certainly with all the functionality of the cloud, been able to rapidly prototype and deploy a custom cloud API that also does some other kinds of things with the data that's coming back from cloud evaluations. And in the course of that, even sort of teaching ChatGPT how to more efficiently use the Wolfram language when it's not doing things quite the optimal way. So, if people haven't seen how this works, certainly there are things that are possible here that are kind of obvious. When you do have access, what's going to change in the ChatGPT interface is, you can choose from different models. One of the models that's going to become available when you have access to the plugins is this plugins model. It's an entirely different thing alongside of versions of GPT 3.5 and GPT 4. But if you choose the plugins model, then you have access to what OpenAI has started this plugin store. And so there are a number of different partners, and there's a Wolfram one. And so you really just click install, and then that will show up in your list of plugins. You activate the Wolfram plugin, and then you can just do, how much is 2 + 2? What happens then is the model says, all right, you know what? I can call Wolfram for this, and I'm going to get some data back from that API. And so what this has done is it's made a call out to just Wolfram here, but you can look at the result and see that this is data that's coming back from Wolfram Alpha. And so this is kind of representative of what the LLM API looks like. Very stripped down kind of Wolfram Alpha. This is your query. Here's our interpretation. Here's a result. And here are forms of all the entrained data that typically comes back in a Wolfram Alpha result, including links to images. And you'll see that, one of the things we've been trying to do is help teach ChatGPT how to pull images out of results that come back from us and include them in results. We can do other things that are, simple kind of entity property query, calls out to Wolfram Alpha. Again, digging in, getting the data back from Wolfram Alpha, and it's all sort of in this just, standard tabular simple form, but it's going to present it in, a nice narrative summary of the information that we got back. It'll pull in charts in appropriate places, summarize some of the other data in the result. There are, certainly you can also do things that are going to probably, this is going to call the Wolfram Cloud, although it's kind of a Wolfram Alpha-y supported input too, but let's see what comes back. Yep, in this case, this said, okay, this is doing a plot, and so it's going to call out. It actually taking that, writing Wolfram language code, feeding that to the cloud, and then getting it back, and we actually get a plot with a, it's nicely labeled. You can build on some things like this and say things like, give that plot a different theme. And so it's going to make a call. It'll modify its previous call and give us something with a different theme from among the things that we support. When you're playing around with the plugin, sometimes the model makes a decision about calling alpha or cloud. Here's an example of kind of how we're using the Wolfram language itself to try to teach ChatGPT a little better how to use it. If I just said, give me Joe Biden's height, it most likely would call Wolfram Alpha directly, because that's more of an alpha kind of question. If I force it to use the Wolfram language, what you're going to find is it just doesn't know precisely all of the canonical names for entities. And so what we're starting to do with the response from this API is say, if you get this kind of error, here's a tip for what you can do to actually get what you're looking for. So we suggest that it goes and it uses interpreter, it makes that call, it gets the right entity expression, and then it feeds that into a correct call and gets that data back out.
I'm going to show another example that is a little bit more contextual. This is an actual AP calculus problem. And again, there's a lot of information, and this is a pretty long prompt here, but we have the problem is talking about fish entering and leaving a lake over a period of time. We have a function for the rate of fish entering the lake. We have a function for fish leaving the lake. We have real times, and we also have sort of the time scale that we're working with from t equals 0 to t equals 5. And as you can see, this is really flying along here. And it made 2 calls to the Wolfram API here. Here, it tried to construct some Wolfram language that didn't quite work. So it ran it again, and this time used env integrate to come up with an answer. And it was able to do that rounding to find the number of fish that entered the lake over a period of time just on its own.
So in addition to like the raw computation and explanation of process, like a key aspect of education is getting feedback on your thoughts and ideas and attempts. So playing around with some prompts, I've found variations of this to be helpful for this kind of conversation. So again, always very happy to help. So here I have a kind of classic math problem of 2 vehicles traveling in different directions. And I've shared my initial thoughts on how I might go about this, and then playing a little bit ignorant as to how I would do the actual conversion there. So it seems to be setting up a nice system of equations here. And I asked it not to solve for me. So it actually listened and respected that. So, I have 2 equations. I have a couple of unknowns, or it looks like just one unknown. But let's just ask it to go ahead and solve. And right away, it's calling Wolfram. So we'll see what kind of result we get here. Okay, so one of the speeds was said to be 24. Yeah, 24 miles per hour, 32 miles per hour. That sounds right, but I don't know what the answer is. So here we're asking it to verify. We're kind of giving it a hint as to how it might go about doing that verification. And it looks good. And then those will add up to, yeah, sometimes it does the math by itself. If it's simple integer arithmetic, it's usually pretty good with that. And this is one that most people can probably do in their heads.